Hey everyone, and welcome. So you're working with Python, and you're pretty much always dealing with collections of items. But which tool do you grab from your toolkit? Today, we're going to break down Python's data structures, so you can make the absolute right choice every single time.
List or tuple? Should I use append or extend? Oh, and what about sort versus sorted? These are the questions that pop up for every single Python programmer. And you might think, hey, it's a small detail, but the choice you make can seriously impact your code's performance, how easy it is to read, and even how reliable it is. Okay, let's jump in and get this all sorted out.
All right, so where do we even begin? The very first decision, and honestly the most important one, boils down to one simple concept: mutability. In other words, can your collection of data change, or is it supposed to stay exactly the same? This is the fundamental split between two of Python's most common data types. So first up, we've got the mutable types. Now, mutable is just a fancy word that means changeable. And the classic example of this in Python is the list. You can create a list, and then later on, you can add new items, you can get rid of items, or you can even change the ones that are already in there. It's built to be flexible, perfect for data that you know is going to change over time. And on the complete other side of the coin, you have immutable types. As you can probably guess, this means unchangeable. Once you create a tuple, that's it. Its contents are locked in for good. You can't add, you can't remove, you can't change anything. And this is a huge deal because it gives you a guarantee of data integrity. What you see is what you get always. So, what does this actually mean when you're coding? Well, this table lays it all out. Lists are mutable, so they come packed with a whole bunch of methods for modifying them. Tuples, being immutable, are actually faster to loop over and they use less memory. They have way fewer built-in methods because, well, you can't really change them. And check this out. This chart shows that memory difference perfectly. For the exact same data, the list takes up 88 bytes, but the tuple only needs 64. And you might be wondering why. Well, it's because lists have to plan ahead. They set aside extra space just in case you decide to add more stuff later. Tuples don't have to worry about that, which makes them much leaner and more efficient for data that's not going to change. Okay, so we've established that lists are built for change. That means Python gives us this awesome toolkit specifically for modifying them. So let's open up that toolkit and really master the most common jobs you'll need a list to do. First up, let's talk about adding new items. You might think there's just one way to do it, but nope. Python actually gives you 3 different methods, and each one is designed for a very specific situation. Now, this is where folks can get a little tripped up, but this slide makes it super clear. Append is the simplest. It just tacks one single element onto the very end of the list. Insert gives you a bit more surgical precision, letting you add an element at a specific spot at a specific index. And then there's extend, which is what you use when you want to take all the items from another collection and add them to the end of your list. All right, so if we can add things, we've got to be able to remove them too, right? And just like with adding, Python gives us a few different tools for the job. Which one you choose really depends on what you know about the item you want to get rid of. This table breaks it down perfectly. You use the del keyword when you know the position or the index of the item you want to delete. You use the .remove method when you know the value of the item, and it'll find the first one that matches and get rid of it. And then you have .pop, which you use when you want to remove an item by its index and actually get that item back to use for something else. And this right here is the secret weapon of pop.pop. It doesn't just delete the element and throw it away, it actually hands it back to you. This is so useful if you need to, say, work through a list of tasks, processing them one by one and removing them as you finish. It's a 2-for-1 deal. Okay, another thing we're doing constantly is trying to get our data in order. Doesn't matter if it's numbers or names, sorting is just a key part of programming. And guess what? Python gives us 2 different ways to do it, and there's a really important difference between them. And this comparison is so important to understand. On the left, you see the .sort method. This sorts the list in place, which means it permanently messes with your original list. It doesn't give you anything back. But on the right, the sorted function leaves your original list completely alone and gives you back a brand new sorted list. So the question you always have to ask yourself is, do I want to change my original data, or do I need a new sorted copy of it? All right, we've gone through all the how-tos, but now for the big question. So what? Why does any of this actually matter when you're just trying to get your code to work? Well, this is where the theory hits the real world. Here is a perfect example from a real-world programming discussion. You know how Python dictionaries store data in key value pairs?
Well, they have one golden rule. The keys have to be immutable. And because lists can change, Python says no way. You can't use them as dictionary keys. But tuples, they're immutable, so they work perfectly. See, this isn't just a style choice. It's a fundamental rule of the language. This brings us to another super powerful tool in our toolkit, the set. A set is basically a bag of unique items, no duplicates allowed. But its real superpower is speed. If you have a massive list and you need to check if something is inside it, Python literally has to look at every single item. But as this quote points out, with the set, that check is almost instant. It's what we call constant lookup time.
So when should you reach for a set instead of a list? This slide lays it out. First, if you only care about unique values, a set will automatically handle duplicates for you. Second, if you're going to be doing a lot of is this item in my collection checks. And third, if the order of the items just doesn't matter for what you're trying to do.
You know, at the end of the day, picking between a list, a tuple, or a set, it's about more than just the technical details. It's about communicating. It's a message to other developers and even to your future self. Using a tuple says, hey, this data is constant and it shouldn't be messed with. Using a list says, this is a dynamic collection that's going to grow and shrink. It makes your code so much clearer and safer. So the next time you're about to type those square brackets or parentheses to create a collection, just pause for a second and think. Your code is telling a story about the data it's handling. What story are your data structures telling? Thanks for watching.